Hello, and I want to welcome you to a discussion on finding the least common denominator. To be able to add or subtract rational expressions, they must have a common denominator. If they do, you must find the least common denominator, LCD. So the steps are to factor each denominator completely, and then the LCD is the product of all unique factors. So let's get started by looking at an example. So find the least common denominator between the two denominators, and that's what we're going to do. So denominators right here are the 2x and 4x. So the higher number, a number that both the 2 and the 4 will go into, if you think about it, will be 4. And think about the variables x and x, they are the same. So you just say 4x would be the common denominator. Okay, so to make 2x become 4x, just multiply by 2. And it's just like multiplying by the fraction of 1. You can write 2 over 2, because what you do on the top, you must do at the bottom. So you multiply 2 over 2 times the fraction 7 over 2x. So multiplying across, you're going to be left with 2 times 7 over 2 times 2x. And you're going to get the desired effect on top of 14 and on bottom 4x. And if you were to simplify this, which to make it look like the simplified fraction, it would become 7 over 2x. But we're just trying to get common denominators. And over here, 21 over 4x. If you notice, 4x is already in its least common denominator, so it is already simplified. So those are the least common denominators between those two sets. Looking at our next set, we have 17x over 4y to the 5th, and we have 2 over 8y. Okay, what I would suggest doing first is to rewrite the first one, since I see I cannot simplify 17 and 4, or the variables x and y to the 5th. But if you look at this one, the second fraction, you can think of 2 as 2 times 1, and 8 could be 2 times 4. So if you were to look, you could say these 2's could cancel out, leaving you with just 1 over 4y. Okay, so we have our numbers down. We both have 4's, which is a good place to start, but we don't have the right amount of variables. So our least common denominator is going to be, we're going to keep our 4's in there, and then our y's need to be the highest of the two, so we need to keep a 5 as the exponent to y. So 17x over 4y to the 5th is already simplified because we have our least common denominator. But here we have to the power of 1. So how can we make 1 over 4y have a denominator of 4y to the 5th? To do that, you want to multiply by 1 as the fraction of y to the 4th over y to the 4th. So it's going to be 1 times y to the 4th over y to the, or 4y times y to the 4th. And on top we're going to have y to the 4th over 4, and then you can add these exponents of y. So 1 plus 4 is 5. So now we have the L, least common denominator, check. Okay, looking at our next example, we have 2 over x plus 3, and we have 5 over x minus 2. Well, for this we cannot use anything in common, so we're going to have to work to both sets. So the LCD, the least common denominator, is going to be both denominators combined. So x plus 3 plus x minus 2. Okay, so for this first one of x over x plus 3, we have x plus 3, so we have to multiply by the opposite as a fraction of 1. So we have to write x minus 2 on both sides. So to simplify, we have 2 times x minus 2, and when we multiply the bottom, we're going to get our common denominator of x plus 3 and x minus 2. Now, in actually solving this, you're going to want to distribute that 2, but for these purposes, you don't have to. Okay, now looking at 5 over x minus 2. Now we have x minus 2 of the denominator, but we need the x plus 3. So to do that, multiply by the other denominator as a fraction of 1. So x plus 3 over x plus 3 is what we're going to multiply by. And that's going to leave us with, on top, 5 times the quantity x plus 3 over x minus 2 times x plus 3. And if you look, we have our LCDs in both cases, so they check out, and that would give us the least common denominator for the polynomial rational expression.